Hi, folks. It's Arvin from Cool Kids Haven. As many of my subscribers, many of you know that I haven't published a single video since December of 2023 or January, I forgot. But after a long hiatus of many different things like school projects and writer's block, or in this case, video block, in which I don't have any new ideas for videos, but finally I do have an idea for video. I think some of you may recognize me or my voice, hopefully, from 2020 when I first presented about the Maurya Empire and also the history of India's flag. Without further ado, I would like to introduce my topic. So first of all, I'm the founder of Cool Kids Haven, which is a kind of like a company I found. Like we have like a website that is still under construction, unfortunately, but we're gonna get our a website updated as soon as we hit our target of 125 subscribers, which is not that far away, only two more. And without further ado, yeah, I would like to begin with our topic, which is trigonometry. Now, some of you may snooze at the thought of trigonometry, but actually, trig is a very interesting field. Like, it's what developed my love for mathematics. Like, I also like history, but mathematics, my number one favorite topic is trigonometry. The trigonometry can be used in many different applicational levels. Like it can be used in the workplace. Like for example, if you're in charge of like a construction company, like you need to build a rooftop at this angle and you need to build and at this altitude, this feet. So trigonometry is everything to do with triangles, but it can also encompass other things. Like sometimes you can graph trigonometric functions. And today we're not going to talk about trigonometric functions, but we're going to talk about some of the basics of trigonometry, especially the triangle part. So I'll just show you all how that looks like. Anyway, oh yeah, and make sure to subscribe to our channel. Okay, it loaded. Um, all right, so we'll start by drawing a triangle. The most beautiful triangle I've ever seen. It's nothing like it, folks. We will draw a triangle stretching at any length, but it needs to connect at two bisectors. What I mean by that is this third line, let's call this line A, this line B, this line C. B and C, B and C need to be perpendicular to each other for this to work. This is what's known as a right angle triangle, or when B and C, the two straight edge, are connected to each other in a perpendicular way. If you don't know what perpendicular means, it's basically when they intersect at 90 degrees. Or you can just, and another way to identify a right triangle is to just identify looking at the box. But sometimes there'll not be a box. So that's when this knowledge comes in handy by using a protractor. So first of all, there's three kinds of functions in trigonometry. One being sine, S-I-N-E, not sin, as some people call it, but the abbreviation is sin. Another function is called cosine or cos, simplified for short. And lastly, we have tangent, or known as tan. So there's three kinds of basic trigonometry functions. We'll get into the inverse next week, but for now, it's just sine, cosine, and tangent, or sin, cos, and tan. So trigonometry is essentially the study of ratios between different kinds of sides in an angle. Sorry, sides, whatever, but sides in a triangle. So for example, if you want to find the ratio between side A and side B, you need to find out the properties. As some of you may maybe some of you may have heard of the Pythagorean theorem, in which a squared plus, sorry, in this case, let me rename the shapes. Yeah, a square plus b square is equal to c square. And let me just erase that. Wait. All right, assume that Q looking letter is an A. Okay. A square, that means a to the power of 2 plus b to the power of 2 is equal to c to the power of 2. Like, this is a good this is known as the Pythagorean theorem, and it's very good if you want to find out the sides of different uh areas of the triangle. Like, a and b are known as the legs and c is known as the hypotenuse. So basically, what happens if you need to find out the angle, let's say between B and C? So for sides, we already got the Pythagorean theorem, but what do we have for the sides of B and C? That's where trigonometry comes into use. So first of all, um, wait, yeah, wait, never mind. This is A and C. Forgot. Yeah, B and C is on the top. Remember, the angle has to be diametrically opposite of the legs. C is the hypotenuse, so it doesn't count. Therefore, the 90-degree angle cannot be considered an average trig function, unless if it's a special right triangle, but we'll get into that in a moment. And the angle directly opposite of A is over here. I'll just name this as A1, B1, and I don't need to label the 90-degree angle because usually in trigonometry no one does that, but we could label this as C1, maybe. So we say that we want to find out the angle of B1. This is where our knowledge of trigonometry comes into place. So sine basically means the opposite side over the, actually let's start with the easy one. Tan means opposite over adjacent. That means the opposite side of the angle over the adjacent side of the angle. That means if we want to find the side of B1 over here, we want the opposite side, and that is B. So that means sine of B1 is B, which is the opposite side, over A, which is the adjacent side. Remember, A is touching B, but B is diametrically opposite, as is shown in this dotted line. So that's for I mixed up sine again. Anyway, this is for tangent. Tangent basically means the opposite angle over the adjacent angle. Now we'll go on to sine and cosine, which are different kind of functions, but with more or less different kind of ratios. So let's say we want to find out the why did I write sine again? Anyway, tan. Okay. I hope there's no more confusion. So now let's say we want to find the sine of the angle. The tan of the angle is B, which is the opposite side, over A, which is the adjacent side. Let's say if we want to find A1. Yeah. So A1 is touching the hypotenuse, which is C, and and its opposite side is A. Actually, we can whatever. Yeah, let's just use the original example of B prime. I kept on calling it B1, so I apologize for that. Um, so for so if we want to find the sine of the angle, then we have to find the opposite side, opposite side, which is B again, over the hypotenuse side, which is the slanted side, which is C. Sometimes the slanted side is less obvious, but in this Example, in typical examples, it's very obvious which one is a slanted side and which one are the two legs. So the slanted side is the one which is not perpendicular to the 90-degree angle, or the one which is facing opposite of the 90-degree angle, as shown in this case. So without further ado, sine basically means the opposite side over the slanted part, the hypotenuse. So as we know from our previous one, the opposite side is b for b prime. So let's see, sine of b prime is equal to b, which is the opposite side, but don't get confused with last time. Like last time we had a for adjacent, sorry, a for adjacent, but this time we're gonna do c, which is the hypotenuse. Remember, a is the leg, b is the leg, but c is the hypotenuse. And basically that's sine. And cosine is basically when you have opposite over, sorry, adjacent over hypotenuse. That means the adjacent side over the slanted edge of the right triangle. So let's use b prime again as an example. What is the cosine of b prime? Yeah, and that is equal to the, as we know from the previous problem, the adjacent side is a. So we need to use a for the first numerator part, and for the denominator, we need to use c, just as in cosine. See how we're combining these two functions together. We'll get into some of these patterns in the future weeks, but for now, this is a basic understanding of trigonometry. So overall, to recap, trigonometry is basically uh anyway. So trigonometry is basically the everything to do with triangles, but the basics that we learned today are what is sine, what is cosine, what is tangent functions, or sin, cos, tan, one idea. And by calculating the ratios between different sides, one easy way to remember this is a method which my teacher taught me. It's called so, sorry. Yeah, I was correct actually. Soh-cah-toa. And as you can see, S means sine, obviously. Like this is a helpful mnemonic to learn from. It really helped me a lot, and I'm pretty sure it'll help anyone else who's also interested in trigonometry. And O is the opposite side. So we'll write OPP for that. A is the adjacent side, so we'll write ADJ. So remember, sine is the opposite side over the adjacent side. Cosine is the adjacent side over the hypotenuse. Remember, the hypotenuse is slanted, and the opposite and adjacent are typically on the legs of the right triangle, or the parts that are not slanted. TOA, I think people can say, is opposite over adjacent, therefore creating the combination soh-cah-toa. And and if we want to find out the exact values of b prime or b over c or a over c or just a or b or c, we need to first give us a sample problem. So let's create another right triangle. This is not so straight as last time. Anyway, so let's say c, or the hypotenuse, is equal to, let's say, 15 centimeters. 15 centimeters, okay? And let's say, yeah, and let's say b is, or the b, which is the bottom leg, is the 12 centimeters. Actually, let's make it shorter. Let's say 9 centimeters. And let's say A is 6 centimeters. Now you want to find out the angle of X. Or as professional mathematicians say, theta. Theta. Which is a Greek letter, which means, I don't know. I think it means T in Greek. I know a bit of Greek. So anyway. So first of all, we find out the adjacent. So we want to find out the tangent. Let's use that. Because tangent is the easiest one of all the examples. So tangent of theta is equal to the opposite side. And what's the opposite side? The opposite side is the one which is not directly slanted, like the hypotenuse over here, or the one which is not directly touching the angle, like this adjacent side here. Opposite is the one which is neither of those, and it's diametrically opposite of the angle, in this case x or theta. So 10 is equal to 9. Tangent of theta is equal to 9 over the adjacent side. As we highlighted earlier, the adjacent side is 6 centimeters because the only other touching side is the hypotenuse, which is slanted. And we don't want slanted. And that's tangent. So tangent of theta is 9 over 6, which can be simplified as 3 over 2, or can be simplified as 1.5. And that's how you solve a... Sorry. But there's something missing. This is not for the angle theta. Like tangent of theta is equal to 1.5, right? But we need just theta. We don't need the tan part. We can isolate theta. Then we can do equals to. But where does the tan go? The tan goes to the other side, right? Tan. But since it goes to the other side, it can have the power will be inverse. Like there's also inverse tan, inverse sine, inverse cosine. Every time the any one of those functions goes to the other side, it becomes a negative power. So that therefore 10 to the power of -1 parentheses 1.5. So these two these two components are multiplied together to form theta. And if you type in a calculator, that answer will be approximately, let's see. And don't worry, this is actually like it's not physically possible to calculate 10 because it's a theoretical function. So theoretically, in like SAT, CAT exams, you're allowed to use calculator for trigonometry questions. So let's go to oh yeah, and here's a handy tip. On the calculator, don't type 10 to the power of -1 because that doesn't work on previous experience. Type in arctan, or if you're on Google, type inverse tan or something like that. I am on Microsoft Edge, but yeah, anyways, type arctan and then type the number which is corresponding to the arctan, the other power, in this case 1.5, and the answer for us will be approximately 0.98. So it's a decimal number, but so our angle will be a decimal. If you want to and that's how you solve basic trigonometry. And I would like to yeah, I would like to finally give a thanks for everyone who enjoyed this video and watched this video, because I haven't done a video in a long time, and I especially haven't done a face-to-face video. And I also want your encouragement and support for my future upcoming videos coming next week. In the next week, we'll learn about radians and in the unit circle. If you don't know what those are, don't worry. Tune in next week. Thank you.